Chapter 15, Calculations for Compounding. After completing this chapter, the student will be able to explain why compounds are sometimes prescribed, perform calculations to determine the amounts of ingredients needed to prepare compounds. So make sure that you, of course, read, through the chapter. But some important things to remember is always be sure you are using the correct conversion factor when setting up your ratio and proportion or setting up your dimensional analysis equations, and always double check your calculations, then have someone else double check behind them. Uh, Pharmacy technicians, of course, should set up compounds so that the pharmacist can check the work before the final preparation. So the first example, and then of course this one is on page 113, and of course you have, it says how much hydrocortisone and how much uracil cream must be weighed out to prepare the following compound. So the compound is hydrocortisone, 2.5% in uracil cream, dispensed 60 grams. So the SIG is going to say apply sparingly twice a day as needed. So first what you want to do is you're going to calculate how much hydrocortisone is needed, and then after that you're going to calculate how much uracil cream is needed. Okay, but it tells you, of course, that you have hydrocortisone, 2.5%, which isn't what percent is going to be grams over 100 grams. Okay, so when you have or doing, if something says like hydrocortisone 2.5%, that is going to be 2.5 grams out of 100. So percentage means, remember, it's always out of 100. So, and then you just put the grams for both of those. Okay. Then, of course, you have your, it says dispense 60 grams. Okay, so down here, this is going to be the total that you want to make, because over here this 2.5% is out of a total of 100. So you'd put here. Now I'm setting it up a little bit different than the book did. I'm doing it in ratio proportion. But then of course you cross multiply. Okay, whatever you multiply the x by goes on the bottom. And then of course you have 2.5 times 60, and that's going to be 150. Then you divide that by 100, and you have 1.5 grams. Okay, so that's of the hydro, well, I'll just abbreviate it hydro, but that's the hydrocortisone. You're going to need 1.5 grams. Okay, and on page 114, this tells you this as well too. So to find out how much uracil cream you're going to need, you're going to take the total of what you want to make is 60 grams, and all you're going to do is you're going to subtract the 1.5 grams because you want to take out what medicine you're putting into it. So take out your 1.5 grams, and of course it equals to 58.5 grams. Okay, so this is of the cream. I'll just put cream as uracil cream. Okay. So when you make this compound, you're going to use 1.5 grams of hydrocortisone, and then you're going to use 58.5 grams of cream. Double check yourself when you add these two together. It'll come up with 6 to 60. So that's the total that you're making. Okay, our next example on page 114, if of course you have 100 grams of your salicylic acid ointment, it contains 20 grams of salicylic acid. What is the percent strength of your salicylic acid in the ointment? This one is actually a pretty easy one to do. All you need to do is you need to take, of course, your 20 grams, and you're going to divide it, of course, by your 100 grams, of course, or your total ointment. And then, of course, that's going to equal out to 0.20, and then you just times that by 100 because it's out of a percent. You want a percentage. Okay, so then you should get 20%. Okay, your next example On page 114, it says describe how much to prepare the compound, and it tells you, of course, you have your Malox, 15 milliliters, your Donatol, 15 milliliters, and then your Benadryl elixir, I'm just going to abbreviate that EL, and 120 milliliters. Okay. And so, so it doesn't, you're just mixing these three liquids together. Since they're all liquids and they're all together, what you're going to do is you're just going to use a graduate cylinder. Of course, that measures 120 milliliters. And first, what you're going to do is you start with the smaller ingredients first. So you put in, of course, first measure the 15 milliliters of your Malox, then to 15 milliliters. Then you're going to place the Malox, of course, in the graduate. Then you're going to add the 15 milliliters of the Donatol. Okay, then you're going to add then place the Donatol in the graduate. And then lastly, you're going to add enough Benadryl elixir to the graduate so that the total volume is 120 milliliters. Okay. So you already have, of course, the 15 milliliters from the Malox, 15 milliliters from the Donatol. That's 30. So then you would need to add 90 milliliters of your Benadryl elixir to get 120 milliliters total. Okay, for this next example, it says determine how much Aura Plus is needed to prepare 250 milliliters of calcium carbonate suspension using the following formula. And I abbreviated these. First one, CC, is calcium carbonate, 8 grams. Aura Plus, I abbreviated O plus, equals 35 milliliters. And Aura Sweet is sufficient quantity up to 100 milliliters. So what this is a formula that has been used previously for 100 milliliters. Okay, but we want 250 milliliters instead of the 100 milliliters. Okay, so we're to determine how much Aura Plus we need of that calcium carbonate suspension using this formula. So we know that, of course, there's 35 milliliters of the Aura Plus, of course, in 100 milliliters of the Aura Sweet, or of the milliliters of the calcium carbonate suspension. Okay, so, and then, of course, you want 250 milliliters of your calcium carbonate suspension. Okay, so we have both the calcium carbonate suspensions on the bottom, and what we're going to do is we're going to cross multiply. So whatever you multiply the x by always goes on the bottom. 100 times x. Okay, and then you'll take 35 and times it, of course, by 250. It's 8,750 divided by 100. And of course, you would need 87, of course, 0.5 milliliters of your Aura Plus to make 250 milliliters. Okay, so this is our next example. It says determine how much glycerin is needed to prepare 500 glycerin suppositories using the following formula. So what it is this formula is for 100 suppositories, and we want to make enough, of course, for 500 suppositories. Okay, so what you want to do, of course, is you know that you have 180 grams of glycerin, okay, in 100 suppositories. Okay, so we're going to take 180 grams over 100 suppositories. Okay, and we know we want to make 500, so our total's down here. We're going to put our other total down here as well too. I like to do everything in ratio proportion. Okay. And then we're trying to find out how many grams of glycerin we need. Okay, so then you're just going to cross multiply. So whatever you multiply the x by, remember, always goes on the bottom. So x times 100 go down here on the bottom. 180 times 500 should equal 90,000. And we could do this an easy way and just take out the 2 zeros, and it's 900 divided by 1. Or if you wanted to divide 90,000 by 100, you'll still get 900 grams of your glycerin. So over here in the box, we needed 180 grams of glycerin for 100 suppositories. Over here, we're going to need 900 grams to make 500 suppositories. Okay, next example says determine how much boric acid is needed to prepare 30 milliliters, of course, of your boric acid, 2% in 70% alcohol. And the 70% alcohol is just the solvent. Okay, so over here, you want to determine how much boric acid is needed to prepare 2%. Okay, so we know 2, and remember our percent sign is 100, so 100 would go over that. And this is going to be a liquid, so we know it'll be milliliters instead of grams there. And we're wanting a total of 30, so our total would go down here with our 100 milliliters. Okay, so we're trying to find X amount here, so we're going to cross multiply. Whatever you multiply, the X by always goes on the bottom. And of course, your 2 times your 30, of course, should be 60. And 60, of course, divided by 100 would be 0.6 grams of, I want to abbreviate BA, boric acid. Okay, so you need 0.6 grams to make 30 milliliters. Okay, whereas 2 grams makes 100 milliliters. So the next section is reconstitution of liquid antibiotics for oral use. Most liquid antibiotics for oral use are going to be shipped from the manufacturer in a powder form for reconstitution. Distilled water is usually used for reconstitution of the oral liquid antibiotics. So in the powder form, the medications have a longer shelf life than the liquid forms. So also the powder forms can usually be stored at room temperature after reconstitution, which means after adding the distilled water. The liquid antibiotics must be stored in the refrigerator, and their shelf life is going to be limited. Usually it's 10 days to 35 days is usually the limit of when they expire. Information about the shelf life on the reconstituted drug, and also how much distilled water must be added to get the desired concentration, is always going to be printed, of course, on that label, manufacturer's label. But there's some things to remember, and it shows you this on page 115. Always use distilled water that is designated, of course, in the pharmacy for reconstitutions. Be careful to read the instructions for reconstitution, rules or instructions on the bottle, and follow the instructions carefully. Be sure to appropriately label the reconstituted antibiotics with appropriate auxiliary labels. Any type of substitution, you always want to put the storage requirements on there, make sure they're on there, and also put a shake well auxiliary label on there. The lumpy liquid antibiotics do not have uniform concentration of a drug, and this can lead to variability in the dosing, so you always want to mix it up. A solvent is a liquid, of course, used to dissolve other substances such as drugs. Usually it is best not to mix liquid antibiotics until the patient arrives to ensure the maximum shelf life is possible for the patient. So usually we don't mix those suspensions until the patient has paid for it, then we mix them up. Okay, if you look at the first example, it says to reconstitute a 150 milliliter bottle of amoxicillin for oral suspension. You have 250 milligrams per 5 milliliters. The manufacturer recommends adding 88 milliliters of distilled water added in 2 divided portions. So you're not going to put it all in at one time. You're going to add it in at 2 different times. First, loosen the powder in the bottle. So usually what you'll do with the bottle is you shake the bottle upside down and kind of loosen it up so it's not all clumpy at the bottom. Then you're going to add approximately 1/3 of the total volume of water and shake the suspension until it looks like it's completely mixed. After the powder is wet, add the remaining water and how much water should be added each time. So the first step is what you're going to do is you're going to determine how much, of course, water to add. Okay, so you're supposed to add a total of 88 milliliters. Okay, so if you take 88 milliliters, you times it, of course, by 1/3. Okay, you'll get 29.3 milliliters. So for practical reasons, you could round that to 29 milliliters. But the second step is to calculate the remaining amount of water. So the total volume equals the volume of the first edition plus the volume of the second edition. So you have this is first step. This is second step. So you have I want a total of 88 milliliters. We're going to round it to 29. Minus 29 milliliters. Okay, and that equals 59 milliliters. Okay, so what you're going to do is the first time, and then you can double check your answers by adding these two together. They should equal 80. 88, I mean. So what you want to do, of course, is add these two together. Add the 29.3 in first, shake it up to the powder is liquid, and it's mixed pretty good. Then you're going to add the remaining 59 milliliters in, then shake it up. Some antibiotics for injections, of course, are also supplied in powder form for reconstitution. We talk about these more in Chapter 27. Your next example, it says you need to prepare 100 milliliters of hydrocortisone, 20 milligrams per 5 milliliter suspension. How many hydrocortisone 20 milligram tablets will you need? So the first step of this is to calculate the milligrams of hydrocortisone needed. So what you'll do first is you're going to it tells you that you need, of course, you already have 20 milligrams in 5 milliliter suspension. Okay, you want to prepare it in 100 milliliters. Okay, so I like to do my everything ratio proportion. The book is using a little bit different method. Use whichever one you like better. But you have 5 milliliters down here, the totals. Then you have x, so cross multiply. Whatever you multiply the x by always goes on the bottom, be 5. 20 times 100, of course, would be 2,000. Okay, then of course you divide that, 2,000 divided by 5, and you get 400. So you need, you're calculating 400 milligrams of hydrocortisone is needed. The second step, of course, is to calculate the number of tablets needed. So you have, of course, 20 milligrams, of course, in one tablet. So you have 20 milligrams, because it tells you in 5 milliliter, which would be in one tablet. And then you have, of course, your 400 milligrams, because it's asking, of course, how many of those hydrocortisone 20 milligram tablets will you need. And of course, you get the 400 from over here. So then you cross multiply. 20 always goes on the bottom because you multiply it by x. 400 times 1 be 400. Then, of course, you can mark out your 2 zeros, make a shorthand. 40 divided by 2 would be 20. So then, of course, your answer would be 20 tablets. Okay, so just work, and I just went through all of these example problems, and what I'll do is I will let you just go. You have the answers, of course, in the back of your book for these. Again, you just have to be careful on how you're reading, the problem. Remember, always know what you have on stock and also know what the question's asking. What is it asking for? Okay. Now, there's several different methods that you could do this in. I did all mine in ratio proportion. There were some of them you could have just done in basic calculations, but I just like to use one type formula for everything, or very similar. Okay. So just do whichever way is easiest for you. If you have problems, let me know. I could go back maybe later and post some more practice questions on this if y'all need them. If you can't come in to see me in my office to go over those. So let me know or email me if you have any questions.